Hello?
Hello.
Hi, how are you?
Good. I'm currently walking to a cafe I'm going to sit down at, but I am in Boston today, so
All right.
I'm back. How are you?
All right. I'm doing well. There's Pakhi. Hello? Yeah, we'll talk about Jesse's trip to Oxford in a little bit, I'm sure.
Yeah.
Hello, Pakhi. All right. So, hello, Morgan.
Hi. I'm just looking for a place to, quiet place to set up here.
Oh, yeah.
Just a second.
Me too.
Yeah.
I'm down in San Jose.
Okay. Good. Welcome. So this week was GSOC decisions. And so we had three people across, hello, Mehul. We got three people across two projects, and I'm including DVORM in this, and I'll show you some slides in a minute to give you a rough idea of how the mentorship is organized or our organizations intersect. So I've invited I've invited all of our GSOC people here. We have two today. Actually, Himanshu is a mentor for the DevoWorm projects, and then Pakhi and Mehul are DevoWorm GSOC students. So congratulations to Pakhi and Mehul. And Jesse and Himanshu are co-mentors on this project, and I'm the mentor. So this is Graph Neural Networks. We also got one student for open source sustainability. Yes. And then we have two people who want to work on projects who didn't get selected, but they will be nevertheless participating in our open source meetings and in some of the other things we're doing. Yes. So it looks like congratulations are in order. We're getting people in the chat congratulating each other. Yes.
Yeah, congratulations. Awesome.
Yeah, so people who weren't selected, don't feel bad. It's pretty competitive. I thought that everyone's application was pretty good. We just had we had to make some rankings, and we got as many spots as we got. So, and then so this is the community period until I think the end of the month of May, and then we'll continue on with the coding period, which is where you do, you get down to the technical aspects of this. So, and then we'll be starting our open source meetings. I don't know about next week. Maybe next week we may have to schedule for a different time, but we'll start either next week or the week after, and we'll do every week where we kind of talk about, we'll give updates independent of any of our other meetings. We can dive into some technical details. We can then talk about some problems, and we'll have like a feature. Sometimes I'll usually present, sometimes Jesse has something to present on, like some topic in project management or in open source or something like that. So last year it was pretty good. We had a number of topics, and those are all up on YouTube if you're interested in seeing. We have an open source channel there. So, and I know that Mehul and Pakhi are from the DevoWorm project, and of course Himanshu is familiar with both the orthogonal lab projects and the DevoWorm projects. And so, this is Pakhi and Mehul. We're going to review your things in the Monday meeting, DevoWorm Monday meeting, but we'll also try to do things in the Friday meeting, so you might want to make those as well, because there's some interesting things going on there. Of course, you can always catch up on those via YouTube. It's fine. So welcome to the summer, and this is our GSOC summer. This is our, I think for myself, it's something like my 7th GSOC as a mentor, or 8th, I can't remember which. And, I've done a lot of different projects in that time. I've mentored people, from a lot of different universities on, basically trying to complete a project over the course of the summer. So, you're in good hands. And then Jesse, of course, has been around for a couple years where he's mentored and, done some mentoring things. And of course, he has his own organization. And then, we have Himanshu, who has done GSOC twice. He did GSOC once in the orthogonal lab, and then the other time he did it in the DiVorm project. So actually, Himanshu worked on both of these projects. So there's the Graph Neural Networks project, and he worked on that last year, and then the Open Source Community Sustainability project, he worked on that 2 years ago in 2022. So he's well suited to be a mentor. And so I would turn to him if you have questions. But we have three, as I mentioned, we have three mentees. So the DiVorm group, we have, which, the DiVorm group meets on Mondays at 2 p.m. UTC, which is 10 a.m. Eastern Time, North America. And we have two people in that group. We have Mehul, Arora, and Pakhi, Banchalia. And Mehul's project proposal title was HyperDevoGraph, and Pakhi's proposal title was Graph Neural Networks. So, I got a question last night in the chat about, contacting each other and sharing each other's proposals. And I say to that, absolutely, please do. Please share resources, please communicate, because we don't want to overlap, because it's the same basic project. We don't want to do the same work twice. We don't want to reinvent the wheel. We don't want to go off in different directions. We want to be complementary. And the way to do that, of course, is to attend the meetings, but also to make sure that you're, if there are common resources you can use, that's great. If there's a common toolbox, sometimes if you say, I'm going to take this part of the problem and I'm going to take this part of the problem, and it benefits both of our projects, then that's good too. Just as long as we're getting something done at the end of the summer. So congratulations to Mehul and Pakhi. And then in the orthogonal lab, we have Sarah Bastawala, and she did a very good presentation in this meeting a couple weeks ago on open source community sustainability, modeling that using large language models and agent-based models. So kind of a combination of the two. And so congratulations to Sarah. And this is the project Open Source Community Sustainability, which we've been working on for a couple of years. Similar to the Graph Neural Networks project, we get students coming in, they complete something over the summer, and we try, in the last couple of years, we've kind of gotten a student to do the work, and then the next year, another student will pick up the ball and move forward on it. And we try to build, sort of a multi-year trajectory using that kind of an approach. So, there are things, we have repositories that you can explore, that are existing. So I encourage you both to go to those repositories to explore what's been done, and then to contribute to that repository, fork that repository, contribute to it, set up your directories, set up your files, and so forth. So congratulations to our 3 official GSOC mentees. We also have 2 other people who applied who didn't get selected for the program but want to work on their projects. So Adama Koita, who also presented in the meeting on her work on developing an immersive VR learning environment for hyperfocus. So this is this hyperfocus stuff in VR where, it's sort of manipulating attention using VR and the affordances of VR. And that's something that, again, this is a great project. And I look forward to seeing what comes out of that. And then Shubham Soni is also interested in the open source sustainability project. And, again, we'll work in, this is that project I just mentioned. So this has been going on for a while. You know, there are all sorts of, we did some things with active inference. We've done some things with reinforcement learning. And so, you know, she's going to work in that space. And I'm looking forward to getting some more work done in that area. So, like I said, we have, this is the community period for GSOC, the next 3 weeks. So the point of this period is to get acquainted with the resources of your community. And so I'll show you in a minute how this is organized. But both DiVaWorm and the Orthogonal Research Lab projects are administered sort of officially and unofficially by the Orthogonal Research and Education Lab. So we have a YouTube channel, and you know, it's the Orthogonal Research and Education Laboratory YouTube channel. We have a lot of videos on there. One of the playlists is Open House and Project Views. So in 2022, we started putting these open house videos up. And this is like a set of videos that kind of go over different projects, go over the state of different projects. And this is a constantly evolving set of resources. So we have, you know, we kind of go over all of the projects we've done, all of the themes that we're involved in. And, you know, so we have a lot of different resources here. There are some resources specific to Google Summer of Code you might want to check out. We also have some, I think there's, I don't see it in this screenshot, but there's some work on VR that is interesting. There's also this State of Open Source and GSOC Activities for 2022, which is a bit dated, but it's still relevant. So there are a lot of, and then the DiVaWorm group update, that was actually from, I think, 2022. So, you know, these are all things that you can find on this YouTube channel and get a sense of what's going on. And so the DiVaWorm group also has a YouTube channel. We also have videos. We don't have state of the project updates there, but we just have thematic videos as well as our meetings. So you can go to those. And additionally, the Orthogonal Research and Education Lab has a channel for open source, in which we have a lot of our meetings from last year where we talked about different topics, and we'll be revisiting those topics. But those are all good resources to get into the community. Speaking of which, our complete org, the way this is structured is that we have the Orthogonal Lab, which is on the left, and that's really an administrative unit for a number of things, a number of projects underlying that, a number of working groups. And one of those working groups is DiVaWorm. Now, DiVaWorm isn't really core to what we're doing because DiVaWorm is also involved with the OpenWorm Foundation. So if you're a DiVaWorm mentee, you were given some community materials for OpenWorm. So I expect you to kind of explore what OpenWorm is about. And that is where, you know, we're looking at simulating the nematode C. elegans. So a lot of the resources I gave you are projects that involve biological modeling of different types. So movement, biophysics, connectomics, electrophysiology, and different things like that. So you'll see those videos. I sent out like a set of resources related to the OpenWorm Open House, which was a long time ago now, but I think it's still kind of instructive of where the, you know, the sort of the points, the access points to that project are. So DiVaWorm is a part of that. It's the development of the worm, but we also do other things in DiVaWorm as well. And so that's one sort of community that you're in. The other community, and the community for our mentees through the Orthogonal Research Lab proper, is the Orthogonal Research Lab. And so this is a group where, you know, we work on different projects, like I said. We work online. We don't have like a physical location where we have people. We all work kind of independently of headquarters. But we do, you know, we try to do our work on different projects. So we try to do those projects sort of fractionally. So we do them when we have time. We're based in the Slack, the Orthogonal Slack. we have a website, we have a YouTube channel, and so forth. So you're in this orthogonal lab, and these resources here, the reason I brought this up is because these are useful. We're kind of getting a sense of all the things that are going on in the orthogonal lab, and even DiVoWorm. And so we haven't built as much connection between the OpenWorm project and the orthogonal lab as I would like with DiVoWorm, but I try to integrate DiVoWorm things into that as much as I can. So I just wanted to give an overview of that. I think that's, it's kind of a cursory overview. Next time I'll maybe get a little bit deeper into some of the things that we're doing community-wise. And, we always try to keep community, because we're a distributed group in both cases, we always try to keep community online like this, where, we have videos, I have other content where we can engage with some of the research themes. Okay, Paola said lots of people today. I'll watch on YouTube. It's fine. If you would like to do that. But hello, Paola. How are you? Okay, so we had a lot of things in the chat here. Let me just go over them. Do we have a question or?
Hello everyone.
Oh, hello.
No, I was just.
Okay.
I seem to be experiencing some network issues today.
Okay.
But thank you for the welcome. And I missed, I think, a small part of the introduction. I'll cover up on that later. And if anyone has any questions regarding the project, you can reach out to me.
Okay, that sounds good. Yeah. So let's see. Mehul and Pakhi aren't in the orthogonal Slack, and I may send you an invite to that as well, because I think that would be maybe useful for some of the open source meeting stuff. So Mehul and Sar are having internet issues, so is Paola. That's fine. Jess says, by the way, if anyone here has Twitter, LinkedIn, or other social handles they would like to be tagged in, let me know. I'm making some posts today, later this weekend, REGSOC and other lab projects. Okay, Mehul,
Yes.
how are you?
Thank you for that.
Yes, yeah. Okay. Shubham is here. Hello, Shubham. Okay. So Sarah said, here's my LinkedIn. So that's in response to Jesse's message. And then Jesse says, I second that. I wish we had more funding slots to give out, of course. And I'm super glad that we will have others in the cohort this summer to work on these projects. Mehul gave his Twitter handle. Pakhi said, thanks, Jess. Here's my Twitter. So we have people on there. So this is the orthogonal research web page. This is where we have a lot of our resources. We have a lab introduction, which Jesse has created. This is where we have, this is kind of out of date in a lot of ways. We have some things that were updated last in June of 22, but it's just lab news and things like that. But this is, so that's that. Then we have people and collaboration, so we have some links there. We have our different sub-projects. We have a link to DiVoWorm and the OpenWorm Foundation. So we do some things with simulating biology. We're also interested in doing things with organoids. We have this neuro-AI category, which is this representational brains and phenotype group. In Cognition Futures, the representational brains and phenotype group is a group that is interested in agent-based modeling and things like that. Open science, open source, we have a number of resources there. We do things with informatics, which includes cybernetics, society, ethics, and tech, and some things on data, open data, and data reuse. We have people, where you can find out, kind of our list of current members and alumni, and, we have some other links here. We have this set of education links. So Jesse runs an organization called JoPro, and this is an intern organization. So we have a link to the JoPro internships, but there's this JoePro site that he runs as well. I don't see it here, but it's joepro.org. And so this is something Jesse runs in with respect to internships and managing that sort of thing. We also have oh, go ahead.
Basically, I'm making a small organization that's around one certain research projects. Cognition Futures is sort of like the original case study. Case study of we're developing very specific projects that are oriented towards getting early career researchers experience in very niche, like interdisciplinary spaces. So half of JoePro is sort of this like a research incubator, and the other half is a sort of mentoring or career incubator, where we kind of have a holistic take on, how does someone navigate the spaces of doing like innovative or more progressive or like maybe less standard pathways to doing research that is actually pushing the ball forward in ways that maybe other places aren't interested in doing research. So yeah, it's sort of a two-sided organization, or two parts to a macro organization that's slowly in development. And there's a few cool things I mentioned that tie into my experience at the Inclusive Gaming Conference at Oxford that I was at, but we'll get to that later on. So a small picture of JoePro, and yeah, I guess we need to update that link. It can just be to the main, the main JoePro page probably, but do that later.
Okay, yeah. So thank you, Jesse, for that. We also have our Google Summer of Code interns. So this is a page, if you're interested in knowing kind of previous year's projects, we have some links here to that. We also have some links to some of our sponsoring organizations. So like I said, the DivaWorm people are part of OpenWorm, but they're also part of Orthogonal Research Lab. Orthogonal Research Lab and DivaWorm are sponsored by INCF, which is the International Neuroinformatics Coordinating Facility. So what they're interested in is, taking neuroscience data and making it more accessible, or figuring out standards for neuroscience data. And so we're kind of affiliated with that in the neuroscience sense. OpenWorm is really about, has strong ties to this sort of neuroinformatics approach. DivaWorm, of course, works with a lot of secondary data. And the Orthogonal Lab, we work with a lot of topics related to the brain, related to cognitive science, and with open data. So there are a lot of not obvious ties to INCF. And of course, they sponsor our GSOC activities. So I just wanted to mention that. So yes, we have a lot of information here. We have our previous interns. So our history with GSOC goes back to 2017, and that was in the DivaWorm group. And so we've been working on sort of different topics in machine learning. We've been working on agent-based modeling. We've been working on other types of topics like creating visualizations for probably, I guess it's been 8 years now, or 7 years. So this is, if you're interested in kind of the history of our involvement in Google Summer of Code, it's at this site. So then we also have, we're involved in the NeuroMatch Academy, which is a summer school that's virtual, and they run a couple of different courses. They run a computational neuroscience course, they run a deep learning course, and this year they're running a NeuroAI course. So NeuroAI is the sort of the merger of neuroscience and artificial intelligence, and this is an emerging field. We actually sort of do some work in that area. I mean, that's what I'm classifying some of these projects as, but this is where you can learn about like kind of the field in 3 weeks, and you learn some techniques. And I do mentoring through there as well. We've been involved in that in the past. And this summer, all the materials are available open and online. So this summer I might actually go through some NeuroMatch Academy lessons from the NeuroAI course in the meeting here, because last year we did that and it was very useful to people to go through some of those materials. And so that, that's something that you might be interested in as well. We have our Slack team links. So we have our orthogonal lab Slack. Some of you are in that. The DiVorm people are not. So if you want to get an invite, you can go to our website, orthogonalresearch.weebly.com. Go to this education tab, Slack teams, and you can get an invite just by clicking on orthogonal lab Slack. And if you want to get into the open room Slack, if you're not in that Slack, then there's an invite for that as well. Then we have our topical Discord servers. So if you're interested in, and this is not required, but this is just some of the things that we have, some of the resources we have. There are a couple of Discords that we run for the lab that are sort of, specialized servers. So we have the Big Unfinished Ideas Discord, which is related to teaching and some other educational things. We have the Principles of Bits to Matter to Mind Discord, which is about VR and XR, so virtual reality and extended reality. And then we have Computational Critical Periods, which is about critical periods in development. So we do a lot of things with developmental science, not just in DiVorm, but in the orthogonal lab as well. And this is on some things we've been doing on critical periods. So we have a lot of resources in the community to go through and talk about and digest. I don't expect you to go to every community resource, but I'm giving you sort of an outline of what we have available here. We have other things here. We have our Medium, which is a blog. So I'm not sure if this year's GSOC requires students to have a weekly blog update. But one of the things we've done in the past is that, the students would have like a weekly report that they'd write up in blog form. They'd set up like a Medium like this, or like a github.io, and they'd have a stub for each week. So each week you would go through your work and you would, kind of make notes, and then you'd write them up as a report. And then in the meetings, we would come together and you would kind of walk through that report, saying, what did I do this week? What did I not accomplish that I wanted to accomplish? What did I do well? What did I succeed at? And what did I fail at, or what couldn't I do? And so if you break it down like that, you can then answer all the questions that you have. Sometimes you can't, but you make a note of it and you say, okay, so this week I did X, Y, and Z. I wanted to do, some other things. I couldn't do them. I may have to wait on some things. If I was successful on some things, then that leads to maybe my work next week. What am I going to do next week? And that might lead to some new opportunities, or it might lead me to my next steps. And, so you can break everything down like that and write it up. So I encourage people to do that if that's the way they want to work. If that's not useful for you, I don't think it's required, but, it's always been useful, I think, to a number of students who have tried it that way. But anyways, this is our Medium. So we have a Medium for the lab. And the lab has, a lot of news that we need to get out and let people know what we're doing. So we have a lot of, if you want to explore this is at medium.com/Arora group. And so this is a good resource to find out some of the things that have been going on in the lab. So we've attended a lot of conferences. We have a lot of conference updates and conference summaries here. We have other types of updates on our research activities. So last year's activities were summarized. We have some special topics, identifying toxic academic workplaces. We have some themes from these meetings. We had one set of discussions on causality last year. We had another set of discussions on physical computing. So we've done a lot of these reports on the things that we're doing. So, but I also want to give students and anyone else who wants to the opportunity to write a feature for this Medium. So if you're interested in writing about some research topic or some topic of interest, professional topic of interest, or something that happened in the meetings that you really wanted to follow up on, or something else, this is the place to do it. And it gives you practice in writing. and it gives you practice in composition, putting together, a report for people to read. So this is.
I'm gonna pitch about writing and the importance of it. But if you want to go to that blog post first, we can. So it's up to you.
Yeah. So I just wanted to say that this is sort of the structure of a blog post. You have some images in it, you have some text, and you try to get the point across. And it's don't worry about being efficient. Just write it out, and we can edit it for you, and you can have something that you can point to on your resume, or it can lead to maybe a paper down the line. But it's an opportunity to get things out there and to organize your thoughts. So that's all I wanted to say about the blog and largely the website in general. So
yeah, and just to briefly follow up on that, like getting experience at how to write for things like that in different audiences, or like if you're thinking about, oh, I'd like to make a small post on like social media or LinkedIn talking about being accepted, and then I'd like to write a like we're open to helping you. I guess there's no particular requirements this year for it, but let's say, for example, you just got accepted to this program, and that's a great thing. So maybe you want to talk about that on LinkedIn, and maybe you want to write more about your project or your experience in a specific blog post. And you can talk to us about that whole process, because we want to help with like the professional development and the skills and the writing. Like, how do you communicate what you're doing both to other people, obviously to us, but also to like a professional network or to other things too. And that's part of what we offer in this summer, and that's why it's really cool. And same thing is true for. That's why I encourage people to be part of like the co-part or the lab in general, because we will help develop all those important things.
Yeah. So yeah, I mean, I guess the point is that GSOC isn't just about working on code. It's about, there's a community period, of course, which is where we're at right now. And that's, just getting familiar with the community, an open source community, how your organization that you're a part of operates, the activities that they're doing, and just, spending time thinking about that, getting familiar with it. You don't have to do, that much, but, it's sort of an immersion for the rest of the summer. And then once you get into that and you understand kind of what's going on, and I encourage people to, explore things, ask questions, whatever. In the case of OpenWorm, we've had people who, they might want to find out if there's an open data set that someone has that they might use in their project. Or if you have, like in the orthogonal lab, we have a lot of resources that aren't obvious. And so if you need something for a project, to find out who to ask and, get those resources in order. So you're exploring your community, you're finding out what's there, you're finding the resources, you're, we're going to talk about open source throughout the summer, but just kind of getting your feet wet in that area, and then also getting ready for the coding period, knowing what community resources are available, and so forth. Now, I also encourage you in the community period, of course, to get ready for the coding period, get your things ready. If you need to set up toolboxes, or if you need to evaluate maybe two different rival approaches that you're thinking of using, then that's the time to do it as well. Because when we hit the coding period, we have a limited amount of time. And the coding period is going to be very, it's going to be very tight in terms of what you can and can't do each week. So I don't want you to feel like I don't want you to spend 60 hours a week on trying to figure out something. We can talk from week to week about how to accomplish things. If it turns out that what you proposed is going to be too big, then the whole point of GSOC is to sort of figure out how to make a project happen without sort of overextending yourself. But you need to have practice at that to know how to do that effortlessly. So a lot of GSOC can be about, kind of finding the right size unit of work for each week to get something done at the end. So we've had this, discussion many times over many years, where, we've had people who they propose something that's, initially looks great, and then they may run into technical hurdles or things might be impractical, and that's fine. We just need to know on a regular basis if those things are workable or not. So that's why we have our weekly meetings. That's why we, kind of get familiar with the community so we know kind of what we have to work with going in, and then having these sort of evaluations each week where we say, okay, where are we? What are we doing? What are we not doing well? What do we need to maybe change? What can we do in the next week? And then, at the end of this program, which is at the end of August, we want to have some sort of finished product to turn in. And so if you're working on something outside of GSOC, that timeline isn't as tight, but you still want to have that kind of model where you don't want to waste a lot of time. You don't want to waste a lot of your time on a project. So you want to know kind of, on a week by week basis, where am I going with this? What's my progress? How can I improve things? Do I need to rescope things? Do I need to change how they're, the size of what I'm trying to accomplish? Maybe I found something that's really interesting that is not in the direction I originally proposed. We can rescope in that way too. So if there's something that's really interesting that you want to do, we may or may not be able to do that, but we have to talk about it. So that's why we want to get familiar with our community. That's why we want to have a good handle on the resources that we have so we can do those kinds of things later. Okay, so I think that's all for the community stuff. I wanted to look in the chat here. We have some more things. Okay, so we have some discussions about LinkedIn and NICWIC, which is something Jesse's going to update us on, and their LinkedIn presence. And then, about the Jitsi, yeah, so Jitsi allows for certain things and not allows for certain things. Okay, so that's good. All right, so that's all I'm going to talk about with respect to the community. So welcome again to our GSOC mentees for this year. All right. So I don't know if Morgan or Jesse wanted to, I know that Morgan has his camera on and Jesse said he wanted to give an update, so.
Well, I'm just glad I found a place that's not piping in really loud trance music, yeah, congratulations everyone. Really exciting can't wait to see these projects coming to life. Update this week. Well, I was back in my hometown, taking care of my aunt. So I haven't. So I've been kind of distracted. But San Jose right now, getting ready for SynBio Beta. So this is a big synthetic biology conference that's been running now for quite a number of years. And yeah, really looking to connect with cerebral organoid people, as well as, some of the kind of side projects on protein engineering, especially as it relates to producing growth factors that you use for organoid development. So we're looking for much cheaper ways to produce these growth factors as one of the kind of most expensive reagents in the organoid culture process.
Yeah.
And yeah, I think 3 of us from Celsius are going to be here. So we're gonna divide and conquer and be I should say that the kids in the group are planning to post lots of things on Instagram. Yeah, I'm the old fogey on LinkedIn.
Oh yeah.
Yeah. But I think Elliot's actually somehow got on a Gen Z panel, and he feels that he's too old for that. And I'm like, you guys are all my kids' age. but looking forward to it. And there's a sleep medicine course that's going on today that I'm also going to be at least peripherally attending. Luckily, recordings are going to be made, but I'm really looking forward to that. And I wanted to just mention, excuse me, Hussein had posted the Neuro-GPT. So, and I don't know if he put a link, but the big update here, the paper had come out, and I posted it, I forget when, but sometime earlier this year. But now the model is available. So this is of interest again for EEG people. USC's produced this foundation model for EEG, and I think it'd be really interesting to start looking at ways to utilize that. I haven't checked Slack, but there's been a few posts. Again, I'm kind of catching up from being on the East Coast. Anyway, might have some more later.
Okay, that sounds great. Yeah, there are a lot of events, and we talk about them in the Slack. So there are a lot of virtual events and events going on, like in the community. And in the Orthogonal Lab Slack, we of course talk a lot about different types of AI models. Talk about large language models and other types of data science oriented models. And then in the DiVaWorm group, we're more interested in sort of graph neural networks and deep learning and things like that. So we have this kind of broad interest in modeling, especially in like AI type models, machine learning type models, language models, things like that. So this is something that we'll probably have in our open source meetings this summer with respect to some modeling issues. And then of course in DiVaWorm is Himanshu, Pakhi, and Mehul know, maybe Jesse and Morgan as well, that we do a lot of things with different types of biological models more generally, so outside of AI. And that's something that I think for the Graph Neural Networks project in particular, something to keep your eye on how some of those models work. So I think people who have been attending the meetings in the last couple of weeks, we've talked about different types of modeling platforms that exist in biological modeling. They're very different from the sort of networks or the neural networks and other things that you're using in AI and machine learning. So it's just always good to keep your mind open to these different ways of doing things and what the results are. So yeah, thank you, Morgan, for that update. Looks like we had some more discussion in the chat about LinkedIn. I don't know. I'm not a big LinkedIn user, so I don't know. And there's a arXiv paper here. This is on Neuro-GPT. So this is
Neuro-GPT, yeah.
So this is the
But I don't
paper.
know much about it, but yeah, sorry.
Oh yeah.
Yeah, there's a. I'll drop a link for the Hugging Face link for the model.
Yes, please do. I think that would be good. So yeah, that's the other thing too is that we want to try to get I think this summer we're going to try to go more in the direction of going to places like Hugging Face. Now the DiVaWorm models, we have models there already on Hugging Face. So we have that org on Hugging Face, and then we have our models in the Orthogonal Lab, which I think for some of the things we're doing this summer with the open source sustainability, we might also try to put some of those on Hugging Face, depending on what part of the model we actually want to publish. But I think that would, because that's a nice community for people to sort of embrace and get your models out there, that people will start using them. Because we put them on GitHub, but GitHub is you have to pull people's attention to GitHub, whereas Hugging Face there's more of a community aspect. So this is the Hugging Face model here for Neuro-GPT. that's just been published, and then the arXiv paper, which is a little older. And this foundation model aspect of for EEG data. So of course the foundation models we've talked about before, but I don't know if anyone has a good definition of foundation models. I don't know if Morgan does or not. Oh, you're muted.
I just think of it as, for the groups that have enough data,
Yeah.
and I think it's interesting. Sorry, I think my watch is speaking. I think there's some interesting things in terms of what does constitute enough data that from a kind of statistical physics standpoint, and that just the Weight Watchers package on PyPy, looking at that in terms of what examining weights of large language models. I think is really interesting, especially with the then with the secondary kind of like LoRa's and things like that. Like now you want to fine tune it. What's happening to the weights in those fine tuned models? Anyway, but this there's it's obviously applying it in a different problem here in the time domain or frequency domain of EEG as opposed to language. So I think it's reasonable to call this a foundation model.
Yeah.
But I think of it that as the term is being used as a model that you then fine tune for something else, right? That like large language models are just capture some structure that then is actually useful in a bunch of other domains. But I don't know. I'm not sure who we would check with to check our vocabulary. Well, Stanford. Stanford. Hey, I found out that Stanford's group is called Hey.
Oh, okay.
It's a human artificial intelligence. And
Yes.
Even though it looks like How.
Yeah.
From 2001, but they do an annual report. So I think they talked about did a presentation on their annual report in terms of maybe someone who can give us definitions.
Okay.
But I wanted to say that Steve Brunton, I dropped two YouTube videos. Steve Brunton did a nice overview of the various courses that he does at dynamicsai.org.
Yeah.
And cover he kind of put pins and operator methods in a kind of overview together with symmetries and what he's potentially going to do new courses on, right?
Yeah.
And that was really interesting. In talking about that, and I really want to revisit that in terms of the Stanford Hay lecture from the chair of mechanical engineering, the way in which she used pins to do model selection, I thought was really interesting. That's the Living Matter lab at Stanford. I'm blanking on her name, but I think her last name is Cool, like Chul. Anyway, that's right. But then also James Glazer's group had an overview of open virtual tissue, and what was nice was an overview of other packages that relate to it, or other packages that focus on particular subdomains of that. that was nice. Again, nice overview to capture, the different software packages in the field and what their strengths and what their strengths were.
Okay, that's great. So we had, I think Mehul wanted to say something. We also had some discussions in the chat about, like, there was actually, Himanshu had a comment about how you not only need data but also compute for your models. So for people who do foundation models, they have the compute, and we, for example, don't necessarily have the compute. So, but yeah. So I guess I don't know, what did you want to say, Mehul?
Hi Bradley. I
Hi,
actually
how are you?
didn't mean to interrupt. I was just like raising hand by mistake. Like I was
Oh.
checking it out when Jess mentioned. But
Okay.
I love like how Morgan mentioned that we need more data, and I completely resonate with like just jump to organization which has more data. Yeah.
Yeah.
Nothing else.
Oh, it's okay. Yeah, so that's great. Thank you and yeah, you can just kind of jump in. I know sometimes it's hard to find a spot, but yeah, if you have something to contribute.
Hi, can you hear me?
Yeah.
Hi everyone. And so I have a couple of things I wanted to say, and I'm also never sure when it would be the right time to say them, so I'll just say them now.
Okay, yeah.
And I have entered. This is for everyone. Hello everyone. It's the first time I see so many people here, and it's good to meet new people. And thank you, Bradley, for the overview of the resources. So that blog post, if you could share the link to the blog, I'm sure I have it and you can find it, and I've already seen it, but it isn't.
Yeah.
And I have shared a link to this Google Doc where I am encouraging people to drop the links and some notes for future reference, because during the meetings I find there's a lot of stuff going around, and I'm finding it hard to follow in real time. And for me, it would be useful to have something to look at later, or even to prepare for the next meeting. If there's something I want to say before I forget, I'm going to write it down there. And I would encourage other Jazz that want to read, so we got his stuff. And in the Google Doc, I have, in fact, I just renamed the program, which is linked. I can link it again, because by now it's benefits were gone. I have entered a couple of things. Question for Jazz. Jazz, you mentioned that you're starting an organization. I don't know when it would be appropriate to discuss this, but some of us may want to find funding, because somewhere I saw that your work doesn't have funding. Your interns, but this I've just pasted in the GT chat. Probably got lost. Your some screenshot is just my talk, because I've linked that in the doc, and it refers to the archive paper that was shared, which I think is relevant too. So in this Google Doc, I noted down a couple of questions, so you don't have to answer now. You may answer later if you think it's there. But one is, Jess mentioned this org, and somewhere in the documentation I read that the org is an informal thing that is taking interns. And but I thought, would it be, if it's, could we look for funding? And if we look for funding, you probably know better than I, because I'm just starting to learn. You need to have a registered organization. So I don't know if that is the case. It would be nice to see if this project takes off. We could look for funding. And oh yes, so Bradley mentioned NeuroMatch Academy. I had a meeting with Nick Helper this week.
Okay.
And talking about other things. And he mentioned that they offer courses. So I went to the website, and I couldn't find anything related to a Solomon lab. So it could be that the courses on NeuroMatch websites are only a part of them are published. And if you could share the links, I'd be very interested to see the intersection between the Solomon lab and NeuroMatch at some point. And then I'm doing design. So in relation to this arXiv data, I gave this very little talk, like where I was saying I'm trying to think of another place, and that's one. I'm also trying to visualize the data set, which I have shared on Slack, which is huge. And I'm not really good at doing practical things with very big data sets. So I was wondering, is there anyone interested in collaborating on helping visualize a massively interesting data set, which I've already shared, but I'm going to make another entry on Slack specifically for this purpose in the channel called the participation, as pointed out by someone. And then the definition about foundational knowledge, I love definition, so I'm going to work on this and provide it next time. And that's it. Thank you for listening.
Yeah, that's great. Thank you for the, and of course, people can edit your Google Doc or they put things in there if they want. I mean, yeah, I guess you can at least comment on it. So yeah, to answer your questions, we don't have content on their website. We do things kind of with NeuroMatch in the lab. So the way NeuroMatch works is that there are materials that they offer to anyone. Anyone can download the course materials, and they generate the course materials, through a series of experts, and they have a curriculum that they use. We can take those and use them the way we want. So we basically review them. We, have our own course content that's separate from what they're doing, but it's based on what they're doing. So that's the idea of open source. We're basically making a fork of NeuroMatch, and we're using those materials in different ways. So we have some.
I got it.
Yeah.
I got it. That's it. Great. Thank you. I've seen those courses. I've seen 3 or 4, which are open source. Normally, there's a mention says you're taking this source, so you can tell where. So they would be on your GitHub, right?
We do have some materials on GitHub, but we also have like YouTube materials. It's hard to, because they're embedded in some of the meetings. We've gone through some of the talks.
Yeah. And we've sort of had these attempts at going through like NeuroMatch slow pods, which if you've gone through any of the NeuroMatch coursework, it's extremely condensed 3 weeks of just rapid fire, day-long sessions of stuff. And what we've tried to do, I don't know if we ever successfully pulled off fully, but there are many attempts or many forms of being interested in these called slow pods that we just go through much more slowly and in depth, the extremely consolidated, extremely compacted materials, and expand them. So that's probably a little bit more of what was being mentioned too. But we don't have as Bradley said, it's not like we wrote material that NeuroMatch incorporated into their stuff. It's maybe more the other way around.
That's very good. That's very nice intersection. Thank you for mentioning that. Yeah. And I think if the material is very condensed, which I haven't actually studied it yet, then it would be nice to have tutorials. So also because one of the things that I'm facing is when I'm teaching, I don't teach coding and I don't teach machine learning, but there's a lot of stuff that you try to explain to beginners or to people who are not English first language. And they do benefit from a level of introduction to terminology concepts. So some people cannot just dive straight into the course. They need to prepare and do a foundation or preparation to get into the course. They need some tutorials before they can take the course, basically. And so it would be nice to develop those, So thank you for that.
Yeah, no problem. Yeah, so the other thing about having a organization that's grant capable, we don't have that in Orthogonal Lab. We can do this through other means. It's just really depending on the grant. I know Jesse talked about using JoePro for that, but it's hard to get. You have to have a board of directors and things. They make it really kind of difficult to do that just kind of for one grant. So but we're trying to work out the infrastructure for things, and so we can do that if we have the imperative to do it.
And just on the side note, this is what was the focus of the meeting with out there at NeuroMatch in Friday. We were discussing how can we partner to leverage NeuroMatch ability to, because they have the full qualifications for that funding. And it's like, how do we work together? So we started speaking tentatively. I think it would be nice to see a partnership with the community.
Yeah, so that's good. Now, we did say something about data. So I think Mehul had a question about data, and Paola talked about data. So, we're interested in different types of data sets. I think next week I might talk about data sets and what's available. We have a lot of data sets that are OpenWorm. I think when you were applying for your projects, I pointed out some data sets to use for training your models or calibrating your models. And then in Orthogonal Lab, we have other data sets that we're interested in working with. If we're interested in doing some visualization, we that would be nice to kind of talk about in the meetings. If you want to, Paola, you're welcome to present like informally on some of your ideas, and then we can talk about them and how to approach them. Then maybe other people will become interested in it. We can have those discussions. Yeah. So
you're talking about the DevWorm meeting.
Well, DivaWorm are here. I mean, we do things in DivaWorm. The data sets are different.
I may not, like my, I'm more of a information scientist. General than a programmer, and I'm not a machine learning person. But whenever I look at a machine learning computation, I need to be able to see it through the human eye. So I do human readability for machine learning.
Yeah.
And if that is useful, I'd be happy to give a talk. That's more or less all I can talk about. But if whenever, just ping me and I'd be happy.
Yeah. Well, yeah, it definitely fits into what we're interested in. So, I mean, I'm interested. We're of course interested in the sort of technical aspects, but we're also interested in the usability and visualization and any kind of way that we can.
So basically, a computational person like yourself, you look at the data as if your brain reads data like a parser, like program, because you are programmed that way. And anyone else doesn't have that imprint in their mind, struggle to understand what is this data. And unfortunately, or fortunately, say that engineers and a lot of managers, funders, a lot of people out there would like to understand what the heck is the program doing and how it's doing it. And it's at the moment it needs a level of interpretation which is very expensive. Just need someone who understands it in plain terms. And I think that can be automated to model card or through a form of explicit natural language annotation. And I also developed what they're called learning interfaces. So for every computational function in the program, you can write a annotation explaining what that does and how. And then it's also a way of learning the program ultimately. So I can do that, and that's what I'm interested in. So anytime you think there is a slot,
yeah, that would be great. That'd be great. Thank you. Yeah. So I think So Jesse had some things to say in the Slack or in the chat here about.
We don't have to get into it. I'll just say it took me a little bit to understand, but there's very specific reasons why things are the way they are, and I wouldn't change it.
Okay.
I think it's a very unique environment that we have here, and I'm not. We should never, get funding or whatever to do in the future. But there's a reason I want JoCo to be a certain way, and there's a reason why I think this environment is a very special one. As maybe unconventional as it might seem in some ways, I think it's extremely useful and a lot of good things come from it. But yeah, I'm hearing someone's background. I think it's cool. I'm just gonna mute that. So, all right. But no, what else do we want to? We're really blazing through today's time.
Yeah, I know.
What did you want to talk about the rest of the meeting, Bradley?
Well, I have a couple things. Well, I have a couple things to talk about, but you can also give an update after. I'm going to do a couple things. You can give an update, and then I'll do another feature. So let me share my screen again. Okay, so I don't know if people are familiar with this. I've always liked this event, and this is something that they have at Carnegie Mellon. It's every April 1st. It's like an April Fool's kind of conference based on computer science. So, and Carnegie Mellon is like one of the best computer science programs in the United States, and they do a lot of really interesting things there. But one of the things the students do is they do this sort of April Fool's type conference where they have like these tongue-in-cheek projects. They call it Sig Bovic, and they have it every year. And this is something that the students put on. It's like they develop these projects, and it's really interesting. They have a live stream, so on Twitch, and they kind of come up with these projects that are sort of useless in the functional sense, but like really interesting. So they have they call the Sig Bovic Special Interest Group on Harry Quelchios Bovic, which is like just something they made up, as an annual multidisciplinary conference specializing in lesser known areas of academic research, such as phylogenetics, denotational semantics of pigeon and creole, and worm causality. So they come up with things that are kind of maybe like joke ideas, maybe they're joke realizations of serious ideas, joke realizations of joke ideas, and maybe, like, I don't know if any people have heard of the Ig Nobel prizes, which are like the Nobel prizes, but they're kind of things that kind of look trivial or ridiculous, but you can actually learn something from approaching a problem that way. So this is, they have this at every year at Carnegie Mellon. Or you could do something in the lab like that if people are interested. I think it's an interesting way to approach problems. Maybe like a smaller version of that where you come up with a couple slides and you say, this is this idea that I had. It's kind of silly, but it maybe gives us some insight, lends some insights into things. So now Jesse said something here. Yeah. So, Morgan said, my definition of ORAL is a modern natural philosophy lab. Well, okay. That's great. Just said, I like how one of the background images in the banner was a decimated house that looked like it got knocked down and fell apart.
I like that too.
Yeah. It's like an alternative to blue sky thinking. Yeah.
Yeah. And I think it's kind of or else sort of like an inside joke, but not like you have to kind of know a little bit about it. But I think it's I'm not going to try to define it here. I understand the questions, but like that can be I'm going to refer to Bradley about demarcating what it is or isn't. But I think the conference is a funny thing, and I'm glad to hear that. I mentioned blue skies thinking, which I think most might know, but like blue sky is where like don't worry about the complications, just sort of put your ideas out there, which is a really great thing for like brainstorming or when you're looking at a problem. And so I said I don't know if I want to call it silly skies thinking, but like I think there is a certain use for like not quite absurdism, but just like a lab mate and a colleague and a good friend who isn't always here, but is always like ever present in my discussions. For those who don't know him, it's Avery. And Avery is uses this sort of technique sometimes, or like it's sort of the understanding the importance of bad art. Like sometimes when you make art, is to be really pristine and precise about like a concept or an idea and being really true, like how high fidelity can it be to that idea that you have, and how like much technical rigor can you put into the crafting of it. But there's also like the use for bad art, as in like art that isn't perfect but is just trying to capture the idea and to share it. So I think there's something to this that fits with that commons idea too.
Yeah. Go ahead, Morgan.
Yeah, I just wanted to say, I mean, you know, I love the search for meaning of oral, but I dropped 2 links for DARPA webinars, and the second I think is interesting too, just in terms of going through. I forget what they call the guy's name. What's the guy's name? It's begins with an H. It's the catechism that they have.
Oh,
Anyway, it's like the
yeah.
7.
Yeah. Innovation.
Heilmeyer Catechism. Yeah, but is just really interesting in terms of thinking about you're thinking about the impact of your project and I just it's a great process to go through, I think, for any project manager, which, you know, we have I think five new ones here, and yeah, it's still interesting to cover that.
So this is one of the DARPA links, or is this something else?
Yeah, they're just doing these webinars.
Okay.
Yeah. It's the first ones relates to the art and innovation fellowships. The specific interest there is that one of the innovation fellows is interested in starting a cerebral organoids program.
Okay.
You know, so I'm still hoping that they'll have a whole organoid track, and that it'll be in the direction of neuromorphic computing. You know, like I think I said last time, like, you know, there's, you know, like the Indiana project, you know, there's things you can do with organoids now that are still, you know, somewhat better and at least functional comparison to quantum computing. But anyway, it's I dropped links in the call for
Well, thank you, Morgan, for that. So the other thing I wanted to talk about was this. So A-Life 2024 is coming up this summer. We sometimes, I mean, we try to participate in it in different ways. This is the Artificial Life Conference, and one of the things that was brought to my attention is this workshop on evolution, criticality, and creativity in collective intelligence. This might be of some interest to, I don't know, some of our people in the group. This is it's a workshop that's being held as sort of a parallel session to Artificial Life. I think they're based physically in Copenhagen, Denmark, but they have a virtual component, I'm pretty sure, because they have a virtual component of the conference. They're basically looking for sort of exploring new frontiers in artificial life research across 3 areas: evolution, criticality, and creativity. And so this is where we've talked about collective behavior before. We've talked about some of the interdisciplinary aspects of that, and this is what this is going to talk about. Now, I think they're interested in a lot of different sort of areas of science, from biology to sociology and art to other areas, bringing fresh insights into A-Life conferences. And so this is that's their goal. They don't have a program. They're soliciting papers. There's a deadline for abstract submission, which is May 22nd. and then you get notified on May 31st if that's what they want to, if they want to include that in the conference. So I don't know if this is, I guess the submission is in the form of extended abstracts or research articles. The extended abstracts are 2 pages. The research articles are 8 pages maximum. If your contribution is a summary of previous results, please specify during the submission process. So this is, maybe of interest to some people. The keywords here are social evolutionary psychology, machine learning and robotics and collective intelligence, criticality in distributed systems, and creativity and group dynamics. So criticality we've talked about before in the group, but that's just a form of complexity. And so they have a lot of different areas. So if you're interested, we can talk about that. I have this stub here, and it might be of interest.
Yeah. Could you put that link in the chat?
Yeah,
I tried to get it.
I'll put it in the. Yeah, it's. Let's see.
Okay.
The site's Google. Yeah.
Okay.
Let me post it here.
Yeah, thanks. No, that's cool. It's maybe we try this a little gap.
Yeah. Yeah, I mean, we always try for things and see if we get them. So, hopefully. So yeah, that's all I had for the updates. Now, Jesse, if you want to give your update.
Yeah, I'll try to be quick. So I know we're almost, 3/4 done. I'm going to briefly mention NICWIC just because it's been really, really great. And then I'll talk about the inclusive gaming event at Oxford, which is phenomenal. It's really good. Also, the big preview for that is that I met somebody there who was working in basically like virtual reality technologies, and they have existing things now, but their future plans are very interesting related to some of our efforts. And I happened to we kind of just got sat together at lunch. We're in that big famous like the Hogwarts dinner hall, and see where you sit at the bench. I have a picture, but I can't find it. You're sitting at the long tables, and I just got you kind of get blocked in, but it also like makes you talk to people around you. And that guy was next to me, and so I had a really, really interesting conversation about like developing and like doing product development in technology, but also like where he wants to go with how to sort of make things more open, and like how to connect between different like virtual environments or virtual environment worlds, almost like going from different websites or making like a WordPress, making a WordPress like WordPress.com or .org, such that you can use this stuff to make a bunch of different websites, and kind of getting that to be like in a virtual reality way and having it be open. I'm trying to get a way to share my screen here. Just a second.
Yeah.
That'll be a window. Maybe this. Okay, I think it's going to be this.
Yeah,
this is working out. Yeah, I'll start quickly by just going about wherever. Yeah, just for this, we are having a call for volunteers for NICWIC. If anybody's interested, you can do some of that remote too. I know, I think almost everyone here is not in New York State, but that's okay. If you're so interested, or you want to get experience about if you want to even just get experience about running conferences, or and this is a very low budget volunteer. There's it's just a group of volunteers putting on a conference for the New York Celebration of Women in Computing. But if you want experience or know-how or some project management or digital project management or even things working to that end, you can do that. And we're open for volunteers that way. But just kind of highlighting how many great stories have been shared on LinkedIn, and I think we've done such a better job of trying to document these stories. It's been so hard because so much great things happen, but we don't really document it. But being able to collect these people sharing about it and tagging our group on LinkedIn, and that way I can easily reshare these like great stories. This is one of our keynote speakers from IBM. This is just another great story of people just sharing their experiences. This is events. This is sort of pictures from the event. I think this is one of our poster winners. Yeah, this person won best poster or best poster. And I think this is it here. But you can just see how, zoom in a bit more, you can see how like, it was such a nice event, and I'm just really proud of everybody who put it together and stuck with it and made it happen this year. So just a big shout out for that. It was very, very, very successful. A lot of really good feedback, and we are starting to plan for next year what we're going to do. Last time I'll probably mention it quick for a long time, but thanks to the people who supported that. We at the lab didn't do we didn't do any research or presenting academically this time, but we've been involved with NUCLIC for several years, and I was a co-chair this time officially, and it was great to work with the team that way, and everybody did a really great job. So yeah, that's just a final sort of spotlight for that. And any questions about that before I move on to the Oxford gaming event? Let's see if I can just pull it up. This is sort of the front page for the event, and then if I can get the games one. Let's see. The print center was amazing. I'll just go here. An overview for it was, I'll start with this. This is, try to zoom in here. Oops, oh, this is a little bit too much. Okay, yeah, we're starting to get to the stuff here. So this is some background for it. It's held in Oxford. It's held at the Oxford Internet Institute in the Jesus College, which is the name of this like very old building from like I think the 1500s is when that like part of the college was made. And so yeah, this is me, and this is Y2K here. We're sitting down currently while this other speaker in our panel was talking. But as part of Plot Twisters, we spoke at this panel on well, first since I'm just here, we'll talk about this. This speaker, who was also in our panel, was talking about reimagining Chinatown, spelled differently, for 2050. And her talk was essentially about using drones to capture existing digital landscapes, but being able to take existing physical landscapes, but digitizing that and being able to both make personalized digital maps of like existing structures. But her main research is about like places and the stories that places have. So she had a really cool discussion about how, she's not a technologist in terms of making the drones or getting the data from them, but what she was also doing is thinking, how can we document or make archives of choices and even potential pathways for the future, or like as we're doing things that don't have digital, in an archaeological sense, you could look at like old blueprints or the tools that were used to make a city or a building or institution. But now a lot of that work is digital. So it's like, how do you document that process of like creating spaces or creating things, creating these like future environments that people may be stepping into? So she had a really interesting talk about that. This is a separate thing. Can't find the original. Okay, here's the talk I was trying to get at. This is a nice shot of us during our talk. This is Y2K again here and me sitting down. But we were talking about Twisterland, which is our sort of first attempt at a gaming product, but how it's going to be interactive online game for fostering diverse personal narrative building is our lofty goal. But the panel that we were on, and also that the previous speaker I mentioned was on, it's called Co-Design Practicing Games, which is essentially about designing with I don't know how to really say it in a pithy way, but it's about sort of stakeholders, but also not just having a more inclusive design practice in general. And we talked in our presentation about both sort of the challenges that we see in like education, ed tech or educational environments that young people may be entering, which kind of makes people conform to a specific standard, perhaps, and sort of the opportunities to, okay, if that's a challenge we're dealing with, how can we create intentionally crafted spaces for people to explore their different ways of having, experiencing the world, or being perhaps neurodivergent, or having very specific emotional needs, or wanting to just get different environments to deal with their personal narratives and have agency around exploring those things. And we talked about both making a game, trying to make a game that way, and then setting up our organization, like how we as a group of people are working to achieve that thing, and how we're kind of trying to experiment things, do it a very different approach. So it was a really cool, a lot to cram into a 15-minute session. We had a few nice questions too, and a lot of really good discussions throughout the day. And let me see what else I can find here. This is the VR person, which I'll get to in a second. There's a few cool posts, but in the interest of time, the last thing I'll mention is I'll share this and I'll talk about this. I'll go over what I'm saying here, but then I'll try to find the actual agenda and share that after I'll just go to another tab to get that. But actually, let me do something here. Are you still seeing the LinkedIn's page?
Yes.
Currently? Okay.
Yeah.
All right, just 1 second. You can consider. Okay, here we go. I got what I was looking for. Okay. I'll go over this agenda in 1 second, but just to cover this, I happen to sit next to Lydia and Ian Shane.
Yeah.
At lunch. I mean, that's kind of what I was talking about before. And just a brief reflection of all that is sort of how we're at a really interesting point in being able to develop very intentional spaces to have very specific experiences people would like to have or might need to have, either just get away from the stress, or to more deeply explore either a stressful thing or something they want to learn about. Like, we have this unprecedented ability to make these spaces, which is really appealing, but also there's still the limit of you sort of have one unit of creation that you have to deal with. And I feel like there were so many great discussions during the panel or the whole conference, but there wasn't really enough time to get into all the bigger, broader concepts at play. So I want to write something about that, and I might make a blog post that can be put on the Medium or otherwise. But it was a really, really fascinating discussion, and I'll just really quickly go through kind of what took place there. Any immediate questions I can answer before I do that?
No.
Okay. But yeah, just super quickly, the opening keynote was very cool, and it was very philosophical, and it kind of set the stage for a lot of things that were both philosophical and technical and sort of almost strategic or market industry based. Co-design practices for games was the panel I was with for Plot Twisters down here. This person wasn't there, which is tough. or I would love to speak with them about that. This is the one Emily Putnam that I mentioned earlier too. I wasn't at this one because it was the same time as ours, but this was playing with the past. And actually, we spoke to this person at the discussion session. But this is a very interesting game for essentially dealing with a very traumatic situation. And how do you make a game where you can deal with someone in that situation and take them through it? There's a lot more that could be said about that, but it's very interesting. Panel session 2, gaming for a purpose, accessibility in gaming. I wish I didn't get to attend this one because it'd be really relevant to my work, but I had some other things to take care of during this time slot. I didn't get to do a lot here in this whole session, but like this is a super interesting and relevant group for me. I actually want to talk more to Dr. Zhang, and one of my friends when I made the conference was very interested in that too. Let's say that alternative modes of gaming and games for young people were both very interesting. It looked at like cozy games versus like really intense walking simulator games that are dealing with a resistance to hegemonic gameplay. Just sort of like things that aren't just like sports games or fighting or like crashing cards around, and like different types of games. And then safe gaming spaces versus protecting games. Actually, it was really nice to talk to Anyi. They were a great set of discussions. And we'll have future discussions too. She's interested in plot twisters. And a lot on like video game patents, which is quite interesting. I was at this panel for this section again. And yeah, that we had a really great lunch session too. And there's things here that we had. And talk about careers. Actually, there's a lot of good advice on careers too, which I won't get into. But like, if you want to talk about that and talk about this panel, just reach out to me because I've been showing a lot of it. You can also find this person on LinkedIn, and I think she has a lot of good advice for like what to do. So that's cool. And then, yeah. Yeah, okay, I didn't get to see the discussion here. But no, that's a whirlwind tour of everything. I know that's just a bunch of like, hey, this happened. But like, it was really, 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 really good. Both for like plot twisters and for getting a sense of where very intentionally minded people are, both like criticizing where gaming is going, building the games, trying to make different kinds of environments for different kinds of opportunity, whereas learning, education, experiencing, play, or relaxing, or getting away from stuff. It was just very insightful. So I'll leave it at that for now.
Yeah, it looks great. Yeah, I'm glad you were able to present on that and get some more things out of that. I saw that thing about the concept to market pathway that you mentioned. It was just in the notes. And it's just kind of interesting from a commercialization perspective. Oh, there you are with your hat.
My hat and my like travel, my face is breaking out, and it's whatever. Actually, the picture background was I didn't have any pictures time in Oxford, but it's like the idyllic fields from when I was there a few years ago.
Oh, okay.
Yeah, that's when actually Avery was there too. But
okay.
Yeah. But that wasn't. I had no time. This whole week in England, I had no time. But go on, you were saying.
Oh yeah, this concept to market pathway. So this is something we could cover in our open source meetings because it's very. I think it's important for like, there's this whole issue of like how do you build something that's kind of and not so much for the machine learning stuff, but definitely for VR. Like, how do you go from something that's a very loose concept to something that you can actually put out and maybe open source, make an open source product where people download it or people would be willing to pay money for it. I mean, it's not just a very simple, like, let's finish the project and make it specific. There are aspects to it that you need to think about. So I don't know a lot of, I mean, I know a little bit about how to do that, but I don't think anyone really has a really good idea of how to do that. That's why I'm interested in that topic.
Oh yeah,
Yeah.
and all, really, I know we know the time, but really briefly, I'll just say like I feel really grateful to kind of had all the different experiences I've recently had, both in terms of trying to make conditioned futures functional, trying to write the papers for that or the projects, and failing sometimes. Like there's things I didn't do. Making like everything I'm doing in my day jobs, and like how do you make a health technology product to the games, like to partridges into what's happening here? Because like in artistic spaces, I'm using the term like unit of creation, which I don't know was a thing, but it's like my current term for it. But you have to make an artistic choice saying, this isn't going to totally be what I want, but the limitations are X, Y, Z, and it can convey this message or convey this opportunity that you can't really make. It's like if when you're writing a story or an essay or something, you have to write one essay, not all the essays that could be written about the subject. When you're writing the paper, you have to write the paper that you can write now, and not all of the papers on the subject. And you have to sort of deal with that limitation. And that's something that I've struggled with, obviously. Like for anybody who's been here knows all that stuff. There's you have to choose. And I feel like this conference has really put that into a new light, or like giving me a space to explore that. And then we're talking to that guy who was also the closing like keynote. We had this extended discussion about like the whole actually implementing it, not just implementing the artistic or creative idea, but then you have to do it in terms of making a VR product, an environment, or even like a coding product or something that requires software and or hardware to do it. You have to have the limitations that you're doing there too. So that can be a great set of discussions to have over the summer too.
Yeah, that makes sense. Okay, yeah, that's great. Well, thank you for that update, Jesse, and I'm glad that your time in Oxford was well spent. And yeah, we'll follow up more on this later. So looks like Himanshu and Paola had to leave. Paola said, thank you for, she's interested in presenting maybe later. She has her document. If you have comments, put them in there. But thank you for both of you for attending today. I'm going to share my screen again. And what we usually do is we usually have features. I like to go through some papers, topical things that I've encountered. So first thing I'm going to talk about today is there's this paper that was in this Slack that was shared. This is, I'm not going to get deeply into this because quite frankly, I'm not that familiar with it, but I think it's interesting from the perspective of some of the things we've been talking about. So this is a paper on Kolmogorov Arnold Networks, or KANs. And so this is an alternative to, I guess, multi-layer perceptrons and some other models like neural networks. So a lot of you who are working on machine learning, this is of interest, not necessarily for your immediate projects, but just for sort of what people are thinking about going forward, because there are a lot of limitations to the classical perceptron, the classical neural network. And so there are other ways you can formulate this. And so sometimes, we think, well, how can we do this? We can look at the brain. We can see how that works. We can look at physics because statistical mechanics, has a really good model of energy minimization and things like that. So we've talked about things like free energy principle and other things. But one trend that's going on in this area is to start looking at some of the physics models that have existed for years and kind of bring those into the world of information processing explicitly. And so, we have different models, like diffusion models are kind of based on sort of a physics, statistical mechanics. There are other models that are based on statistical mechanics. There's a lot of physics-based neural networks. So in this case, they're looking at these Kolmogorov-Arnold networks. And there are a number of authors on here, including Max Tegmark, who's a physicist. And so the abstract reads, inspired by the Kolmogorov-Arnold representation theorem, which is something that, I'm not going to get into. We propose Kolmogorov Arnold Networks, or CANs, which are a promising alternative to multi-layer perceptrons, or MLPs. So a perceptron is, sort of the basic unit of a neural network, where, you have a bunch of inputs to a single perceptron that classifies the inputs in an ordered way. And so, this is something that is, has weights, so the inputs are weighted appropriately and you get your classification. So they compare CANs to multi-layer perceptrons. Well, MLPs have fixed activation functions on nodes or neurons. So the neurons are the nodes. The activation function is a way to sort of activate different inputs to the neuron. And it's based on weights, but it's based on rules like RailU and other things. CANs, by contrast, have learnable activation functions on edges or weights. So, we have our weights, we have our edges, we have our nodes. The edges have the weights, the nodes are these processing units, and then we have our activation functions. So let me see if I can draw this out on the board. A multi-layer perceptron, you kind of think about this as having your different inputs, and they come into this neuron, which is here, and then we have an output from that neuron. So we take the inputs, and what we want to know is, like, given a certain amount of each input, what is, can we classify the output? And so each of these have a weight, which is usually some decimal value, and then we have an activation function, which is where you have, I don't know, it could be a logical function, it could be like a specific type, like a sigmoidal function. It could be a lot of different ways to activate the neuron. So it's based on, inputs to a neuron in biophysics, but we're doing this computationally. So that's how we have our perceptron, or MLP. And so we have basically nodes here, weights are here, and our activation function is here. All right. So that's basically how this works. And the activation function, we could use like a step function or a sigmoidal function. Basically something that triggers the activation of this neuron to put it in, give an output that is in a certain class, so it's either on or off. In biophysics parlance, it could be in different categories as well. So they're saying here in this paper is that our multi-layer perceptrons are fixed activation functions on nodes. So we use the node as a way to sort these inputs. We have a single activation function that we use, and we make these categorizations. In CANs, we have learnable activation functions, which means that these activation functions are, tuned to the data. So we don't have like a single, we can't just say everything is subject to a step function or everything is subject to a sigmoidal function. We actually learn the function. And so they might look weird to us. So we have our step function, we have our sigmoidal, and we know these. We have other methods to look at different functions. What they're saying is that you're learning it. So it could be a weird kind of activation function that could be like multimodal or something else. So that's what they're getting at here. And the idea is you're learning from the data. You're not imposing an activation function. But it's also this aspect of learning, or it's a learnable activation function on edges. So the weights are actually important here. What are the weights? And it's taking the information about the weights, and it's using that to learn the activation function. So CANs actually have no linear weights at all. Okay, so in our model of the perceptron, these are linear weights, right? You can combine them linearly, you can treat them as linearly separable. CANs have no linear weights at all. Every weight parameter is replaced by a univariate function parameterized as a spline. So a spline, of course, fits the data. If you have a bivariate representation, if you have a bivariate representation of data points, and they exist in this bivariate space, you can fit it with a linear function like this and kind of predict from there, but you have a lot of variance perhaps. So in cases of high variance, it's not really useful to have a linear function like this. And this would be like a typical activation function where you're fitting your data to a linear function. Spline, on the other hand, is where you find the best fit, but you kind of move through your data points like this. So you find the nearest neighbor basically to that function. And then this informs your activation function. So it can be very different than a normal activation function in a perceptron. So we show that the seemingly simple change makes CANs outperform MLPs in terms of accuracy and interpretability. So for example, we know kind of what a CAN is doing more than an MLP because it's learning. There's a function, we look at the function, we say, okay, it's basically learning the distribution of the input data, whereas MLPs are just kind of imposing this linear regime, normalizing the points, but we don't know kind of what the, it's hard to interpret the output. But it's also more accurate because you have a better approximation of the points. For accuracy, much smaller CANs can achieve comparable or better accuracy than much larger MLPs in data fitting and PDE solving, or partial differential equation solving. So, differential equation solving is a nice problem, benchmark problem, but also data fitting, and we can do both of those with CANs over MLPs. Theoretically and empirically, CANs possess faster neural scaling laws than MLPs, which is this idea from neural networks where you have this, the larger the model, the more sort of competent the model is, or the better the performance. And so, yeah, they talk about that in the paper. For interpretability, CANs can be intuitively visualized and can easily interact with human users. And so you can visualize these intuitively. Through two examples in mathematics and physics, CANs are shown to be useful collaborators, helping scientists rediscover mathematical and physical laws. So they use CANs to discover mathematical and physical laws, which are these regularities in the data that we often, like to think about in physics. We like to think about linear scalings and, patterns. And so we can do these things with a CAN. And we can do these things with a perceptron, but not as well. In summary, CANs are promising alternatives for MLPs, opening opportunities for further improving today's deep learning and models, which rely heavily on MLPs. So the lesson here is that CANs are better than MLPs. So we have CANs, MLPs. And we can do different things. We have discoverability. Interpretability. And then, it can, scaling. So we have the scaling aspect as well. So, yeah. So, okay. So let's see if we have, this is a sort of a graphical abstract here. So we have multi-layer perceptrons on the left and Kolmogorov Arnold networks on the right. And this table kind of summarizes things in terms of different aspects of the models. So we have the models, the theorems. Multi-layer perceptrons use the universal approximation theorem. Kolmogorov Arnold networks use the Kolmogorov Arnold representation theorem. So this is, again, in multi-layer perceptrons, you have this universal approximation, whereas in Kolmogorov Arnold, you have this more specific type of representation. And so the formula is thus, in multi-layer perceptrons, you're summing the inputs, you're doing this linearly, and you're getting this function. In Kolmogorov Arnold, or it's equivalent to an activation function. In Kolmogorov Arnold representation theory, you have this function that's equivalent or equal to these summations of the data. And so this is basically, it's a different type of formalization. You have these two different models. So in the multi-layer perceptrons, like I said, you have a bunch of, you have fixed activation functions on nodes, you have learnable weights on edges. You have these, in Kolmogorov Arnold Networks, you have learnable activation functions on edges and summary operations on nodes. So you have these activation functions with a middle layer of nodes and a top layer of nodes and a bottom layer of nodes. So it's a little bit different structure of the network. And then for the formula here, for MLP, you have this formula here. For CANs, you have this formula here. You're basically substituting, I think, the variance for this other term. And I don't know the details. I'm not going to get into the details, but it's a different way of thinking about it. And then for your deep model, you have, so this is the shallow approximation here where we have like a 2-layered system. For the deep system here, we have, these different layers, and we're doing this sort of thing on, we have the fixed activation functions on nodes for multiple layers. We have these learnable weights on edges for multiple layers. Then in CANs, we have the same model as we have in the shallow case, but we're kind of learning, so it's nonlinear and learnable versus being nonlinear and fixed and linear and learnable for multi-layer perceptrons. So the nonlinear aspect is learnable in CANs. The linear aspect is learnable in MLPs, but in CANs, that's less relevant than the nonlinearities. So it's very good for problems that are nonlinear. And so basically things that aren't very simple problems. Okay, so that's a newer approach, newer paper, and it's a very quick overview, but I just wanted to get through that and make people aware of that paper. Okay, any questions, comments?
No, I'd be really interested to cover that more. It's really lit up all the machine learning blogs, and yeah, it's got a great pedigree, and and I think it's the use of splines, going back to Grace Waba, have been, it's a somewhat overlooked topic, but when applied well, have always been incredibly powerful. So I think it's just interesting to introduce them into the architecture like this, and see what can happen.
Yeah, and the key here is implement well, because splines are notorious for overfitting. Like you can have a spline that overfits the data as well, so it can be a problem.
Yeah. I mean, totally. Again, it's one of those. Yeah, it's one of those topics though where if you can find that middle way with them.
Yeah.
That's again the power. What she showed was just how they made. I mean, this is like 80s, 90s, but was making particular problems in climate modeling tractable. Right. And at least again, like I haven't played with this at all, but it seems like what they're kind of touting it as is like when done right, this is providing an incredibly efficient representation that can with a smaller kind of footprint is explaining much larger NLP models, or is handling the same as larger NLP models. So yeah, again, I think it looks really interesting.
Yeah. So yeah, the other thing then is this tractability issue, or I guess nonlinear tractability. We'll add that to our list of things that it does over MLPs. And so this is important for finding rules and laws in nature, because we have a lot of laws that are kind of, we have things that are very simple linear relationships. Like we'll have a bivariate relationship that we can say it's a law, and we might test on a very simple data set, and then we might go to a very large or complex data set and it might not hold. On the other hand, there are a lot of laws that we don't know because the law is just too nonlinear for us to sort of visualize easily and extract out of a data set. So if it's like we can take psychophysical laws as an example. There are a lot of psychophysical relationships that are like, if I show you an intensity of light, your response time might be conditioned by the intensity of light. So the higher the intensity of light, the faster you respond. The lower the intensity of light, I'll respond slower to, say, the change in the intensity of light. So if the light changes very quickly, if there's a bright flash, I'll hit a button. If it's like a very slow change in intensity, I'll say, okay, there it changes, and I'll hit the button. And so that can be characterized as like something that's a linear function or like a log function, which is slightly nonlinear. But what they're saying is that you can have data where people not only do this, but they do it at different scales. They do it in different ways that have a lot of nonlinearity, have a lot of these sort of where you might put a spline, like a third or fourth order spline, and you'll get this complex pattern of responses that don't match that kind of simple line or simple function. So the function is much more complex. Maybe there are different populations that behave differently. Maybe intensities of light, it doesn't saturate. There's actually some other aspect of the performance. And so this is good when you're dealing with a lot of data where you have a lot of potential patterns, a lot more than if you had just maybe 1,000 data points. If you had 1 billion data points, you're going to have a lot more opportunity to observe a lot more modes of behavior. But also, when you have these kind of systems where they're just the response is just too nonlinear to get with a simple bivariate relationship, and you need maybe higher dimensional things that can be summarized in 2 dimensions. So yeah, definitely interesting. And this is like, in machine learning, people have run up against a lot of these problems, and they've been trying to figure out how to get at them. So this is one such attempt. So that's great. So the other thing I wanted to talk about today is this interesting set of papers on exercise. This was, I think I don't know if I posted this or someone else posted this, but this was a paper on multi-omics and a response to exercise. So basically what's happening here is they're using a mouse model to look at the response to endurance exercise training. So you can put a mouse on a wheel and you can train it to run on that wheel for a long periods of time, and then look at the response of the muscle, of the physiology of the mouse. So this article is called Temporal Dynamics of the Multi-omic Response to Endurance Exercise Training. And what that means is that you're interested in the time series that are generated by the response to exercise. So if I put a mouse on a wheel for say like 2 weeks in different training bouts, there's going to be a response within the mouse, the physiology of the mouse. And it's going to have a lot of different scales of response. So you have these very short-term responses, which are these early genes that are expressed. You have other types of genes that are expressed with respect to stress, with respect to metabolism, and so forth. And then you have these longer-term responses, which are adaptations, sort of the benefits or improvements of training and so forth. So this is where, we need to kind of tease these things out. We can actually, from the temporal dynamics, we can also tease out the relationship perhaps between what's going on at the molecular scale and what's going on at the phenotypic scale. And so we talked about a data set a couple weeks ago on mice and early immediate genes. It was an atlas of data, and so this is, I don't think this is related to that, but there is this. So this is put out by the MoTrPAC Study Group. So this is MoTrPAC. It's a very tortured acronym, but this is the group that's behind this. I don't think it's the same group. I think it's a different group. But anyways, they're looking at this problem. They're looking at this response to endurance exercise training. So if we read the abstract, they say regular exercise promotes whole body health and prevents disease, but the underlying molecular mechanisms are incompletely understood. So we don't know, well, we know, we maybe don't know the molecular mechanisms. We have data on the molecular aspects of this. But aside from those mechanisms, we're trying to link what's going on at the molecular scale to the phenotype. So if we have gene expression, we want to know what that causes in the phenotype. Or does that cause other parts of the molecular milieu to change? So what they're interested in is the MoTrPAC stands for Molecular Transducers, a Physical Activity Consortium. And so you can take out the letters as you will and figure out how that translates. But basically they want to profile the temporal transcriptome, so the things that are transcribed in the genome over time. They also want to look at the proteome, or the production of proteins over time, the metabolome, or changes in metabolism over time, the lipidome, or changes in fat composition over time and different types of lipids being produced, the phosphoproteome, which is the production of phosphorylation events. So proteins and a lot of things at the molecular level are dependent on phosphorylation. So there's a lot of these phosphorylation activities that are involved in regulation. And there's this, there are like multiple phosphorylation events that can occur, that have to occur to regulate different molecular products. So, there's this whole language of phosphorylation. So you can look at phosphorylation as an ohm. Acetylproteome, ubiquital proteome, epigenome, and immunome. So basically they're looking at a lot of these different sort of spheres of influence, different aspects of the molecular milieu, from producing different types of biochemicals to producing proteins, to the response of genes, to the response of the epigenome, and so forth. So they're looking at all these different things and they're trying to put them together. And as you can imagine, it's quite complex data set. And it's going to be very hard probably to get some insight out of this, but let's see what they do. So they take whole blood and plasma, which are the samples that they use so the rat runs on the wheel, they sample the blood and plasma, they get the molecular information from that. Things are upregulated, things are downregulated. They get it, you see evidence of that in the blood and plasma. So and solid tissue, so they actually can get solid tissues out of the specimens as well. The sample size is, I think, 18 or 19 for training points, but this is enough to do some pretty good analysis. So they're looking at male and female Rattus nervigicus, which is a model rat, or a model organism of rat. But they're, this is typical. You use some sort of murine model, which is a rat or a mouse. You put them on a wheel. It's a very simple model to assay. It's supposed to be an analogy to humans. We've talked about this in the past. Of course, there are differences between, mice and rats and humans, but I think it's good enough to get a sense of these kind of changes. So they do 8 weeks of endurance exercise training, and they take 4 time points within that 8 weeks. So they're looking at like 2-week intervals. So over 2 weeks, you can have a lot of changes, but over 8 weeks, we can have a lot more changes. So thousands of shared and tissue-specific molecular alterations were identified, with sex differences found in multiple tissues. So we're looking not only at some of these changes in the molecular milieu, all these different parts of, these measures of molecular change, but also sex differences, so between males and females. And we find this in multiple tissues. So if we sample, say, like muscle versus heart muscle versus brain versus, epithelium, we get all these different responses. And we get sex differences as well. Temporal multi-omic and multi-tissue analysis revealed expansive biological insights into the adaptive responses to endurance training, including widespread regulation of immune, metabolic, stress response, and mitochondrial pathways. So these are we would probably guess this from just kind of thinking, if you know a lot about physiology, you think, okay, these are the places where we'd expect to find changes, and there's a lot of regulation there. So, I mean, it's not just as simple as saying that. You have to look at the data. And of course, it's much more complex than just saying that. But if we look at the immune system, for example, of course, we're going to have an immune response to exercise. Exercise is what they call a challenge to the physiology. So, exercise, it's almost like a stress. If you do a lot of exercise, you're changing basically your sort of, equilibrium point or your homeostatic point. And so there are going to be a lot of changes in different systems, and they may or may not correspond to one another. So you would expect the immune system to change, because the immune system is like that. If there's a challenge, it tries to adapt and learn from that. The metabolic system, which is, of course, metabolism, which means that you have changes in metabolism corresponding to needs in the exercise regimen. If you need to, say, build more muscle, then you build more muscle. If muscle needs to break down, it breaks down. Fat breaks down. Things happen. Then the stress response of mitochondrial pathways. Mitochondria, of course, is involved in energetics, in producing energy. And then the stress response is, of course, because this is a stress, exercise is a stress on the bone, stress on the muscle. There's catabolism of muscle as well as metabolism. There's also the stress on bone, and so bone needs to be remodeled. And so that's where we're getting all these changes. Now, they say that many changes were relevant to human health, including non-alcoholic fatty liver disease, inflammatory bowel disease, cardiovascular health and tissue injury and recovery. So all these things are implied from sort of the data that they've collected. The analysis that they give actually implies that these sorts of, their exercise regimen does things to the physiology. A lot of times it's good, but sometimes it can be deleterious. And it just depends on, the way that you approach the exercise regimen. But there are also changes that are relevant to human health. So, activating certain pathways, either through exercise or through some artificial means, can affect these different conditions in humans, just because they're, they find that some genes are involved, say, in some disease or disorder, and there are genes that get changed positively with exercise. So they're making that connection. And so you're making actually two assumptions here. One is that what you're studying in the mirroring models is relevant to what we have in humans, that they're many shared pathways, but also that that these shared regulatory mechanisms, these shared changes in molecular expression are going to have an effect. So if we do some intervention with exercise, it improves condition X because they share a molecular underpinning. So that's what they're getting at here. The data and analyses presented in this study will serve as valuable resources for understanding and exploring the multi-tissue molecular effects of endurance training, and are provided in a public repository, which is this MoTrPAC-data.org site. So this is their data hub. So this is their consortium, and this is its goal is to study the molecular changes that occur in response to exercise, and ultimately to advance the understanding of how physical activity improves and preserves health. And they want to generate a molecular map of the effects of exercise. So this is where we have, you can explore the data, their different publications. This is actually some of the graph characteristics. So this is so they sample an 8-week interval, week 1, week 2, week 4, and week 8. They have what they call analytes, which are the sort of the, what they have in terms of the effect size, and then they have everything color coded. And you can explore the visualization. So this is the exploration of this visualization. You can simulate this by changing the parameters. You can get, you can explore the data set by sort of stratified by gender and by change in different tissues. and then also by these time points. So you get these nice trajectories over time. Actually, I'm not sure. This could be that same group. Let's see what their publications look like. Oh, it's not the same group. This is a national group, but they're, yeah, I don't know what this. It could be some of the people from the other group too, but I'm not sure. In any case, they've published a lot of things in this area. So this is it's a nice resource for looking at the effects of exercise, the effects of adaptation, and things like that. So this is kind of a final shot of what they're doing here. This is the rat. It's kind of laid out in this way. And you have these different tissues that they sampled. So they sampled from the brain, from the heart, from lung, liver, spleen, kidney, adrenal gland, ovary, and then the intestines, the testes, and I don't know if they sampled from the skin. So there are a lot of different tissues that they sampled. They did these training regimens over time. They changed the incline. So this is the rat on a platform here. I guess they're on a treadmill. You can see it here. And the treadmill sort of inclines and that's sort of an index of difficulty over time. So as it, kind of gets used to being at like a 10-degree angle, they tilt it to a 45-degree angle, and it makes it increasingly harder for the rat to do its exercise. But it's getting more used to doing exercise. So this effect is increasing. This incline times duration times speed is increasing with increased training, and that's having an effect on the tissues in the rat. So we have, these weeks of training. You start with sedentary rats, male and female, and you go to week 8. And then they, of course, harvest the organs. They get blood and plasma, and they analyze all of that. They do the chemical analysis. And then you end up with a graph like this where you have the different measures of different types of systems that we want to look at, and then the different tissues and different sources of molecular information. And then we have our differential proportion of analytes across these different types of systems. And so these are we have genomics, proteomics, metabolomics, and immunoassay. So that's the color coding here. And then, so that's the kind of data you end up with, this sort of matrix. So that's all. I just wanted to go over that paper because I thought it was a very cool paper, and we've talked about this in the past. And so, okay. So Jesse put a link to the LinkedIn post on the KAN or the Kolmogorov Arnold Networks paper. It's been blowing up on social media, as they say. And then so actually Mehul had a question about that paper. Very interesting paper. I wonder where it's submitted. It mentions under review. It could be to one of the machine learning conferences. I didn't understand how it's interpretable. So Morgan, did you have any thoughts on that? On how KANs are more interpretable than perceptrons?
I'm not sure if I've got that yet. I think there's just. I think they're making the claim that that a smaller model will lend itself towards that.
Yeah.
That it'll be easier to identify I think isn't that kind of the criticism with deep learning, is that that on one hand it handles kind of the feature engineering for you, on the other hand because you don't really understand how that was formed, it becomes less interpretable, and so you do all this kind of post hoc work to examine the weights and things you can somewhat think about it as like a smaller model gives you in the general linear model kind of framework, a smaller model gives you a more interpretable design matrix that lends itself to the, you know, which factors are important. Again, I'm dropping down into the linear model.
Yeah.
but I don't know if that helps, right? I mean, or if that seems right. But I really haven't looked at it. Like I just saw every single kind of ML group log or blog cover this paper and say stuff about it. And so really interesting to look at, especially from the sure. I mean, like, let's not just pass this over. I think it's going to be. I think it's interesting to follow up on this, especially the because it does kind of relate to this scientific law discovery.
Oh yeah.
Mode of I don't want to just say deep learning, but just machine learning in general, and somewhat towards, again, like cover the Steve Brunton overview of all his topics in terms of and again, remembering that he's the co-director of the Dynamics AI NSF Center, like and that's it, right? It's like, can we in an unsupervised way find the governing equations?
Yeah.
Sort of, right? Yeah. So it does look interesting, and again, I when I had seen it like pass like all I thought in my own head was just like, why don't I know the Kolmogorov Arnold's representation theorem?
I don't think a lot of people do. That's kind of the point.
I was like is I take it it's not information theory, right? But I don't I don't know. Or I certainly think of Arnold as being well, I mean Russian maths at that time definitely going to be like PDE, and so.
And there's Kolmogorov information theory, which is
right. Which is so let's see if we can find some. I haven't played with it enough to see whether there's some good toy models to work with, and like in their examples, for instance.
Yeah. The benchmarking is always the key.
Yeah, but but do their particular examples give us nice intuitions as to how this is going to behave differently, or more interpretably? I don't know. But
so I had a point on this. Yeah. So what it's doing is it's learning the activation function. So if you just say put out like a sigmoidal on something and say behaves according to a sigmoidal. Well, there might be different reasons why it performs well with a sigmoidal. So you don't know like exactly what how the data map to that activation function. There can be a lot of ways, and so you can't interpret that. If you're learning an activation function, then you have a unique activation function for any one set of data, and so you can say like, okay, there's this multimodality because it's there's this pattern in the data. Or it makes it a little bit more interpretable, but I don't know if maybe that's not always the case. Like it could be less interpretable, depending on what your definition of interpretability is.
Yeah. Again, this isn't how my mind works, or like I need to see it in a toy problem,
right?
Or with I need to feed it some particular inputs that will help my intuition.
Yeah.
But it would be really interesting, and just about the exercise. Well, the multi-omics and exercise again super interesting what they're doing as an example, just as a great example of kind of modern physiology research.
Oh yeah.
You know, I mean that's like, again, you know, taking examples of groups doing it right, even for you know, in this case exercise, but then thinking about how you know, how we're not doing that for psychiatry,
Yeah.
right? And that, like, and this is just exercise,
Right.
right? This is just the, like, you know, like they're running in a, you know, I mean, like, you know, just yeah. I mean, this is you know, we all have this machine at the gym.
Yeah.
But just how much more complicated the physiology that we're talking about is for, you know, for cognition, memory, you know, all the varied, you know, aspects that are potentially influenced in mental health issues, and yeah, so it's great to see and great to learn from.
Yeah. All right. Well, thanks. Yeah. And so yeah, everyone else had to go, so that's fine. Thank you for attending. And all right. So yeah, thanks for attending. We had a good meeting, and let's keep up the conversation in the Slack, and we'll probably do another
Take care.
GSOC related event next week. Take care.